The zero product property is the tool that allows us to actually solve quadratic equations. So a polynomial equation is any equation that contains a polynomial expression. The degree of the polynomial equation is the degree of the polynomial expression in the equation. So 3z plus 7 equals 1 has a degree of 1 because the highest exponent on our variable is z, and the largest exponent there is a 1. So makes it a degree 1. For 4k squared minus 5 equals 0, the variable here is k, and the largest exponent is a 2, making this a degree 2 polynomial. 8x to the 4th plus 4x cubed plus 5 equals 12. The largest exponent on our variable x is a 4, making this a degree 4 polynomial. The zero product property tells us if the product of two factors is 0, then at least one of the factors is 0. That is, if a times b equals 0, then a equals 0, or b equals 0, or both a and b equal 0. Makes sense? This is very lovely and already factored for us. It doesn't get much better than that. So this was a trinomial, a quadratic equation in trinomial that was already very nicely factored for us to x plus 5 times x minus 5 times x plus 4 equals 0. Because the result is 0, then either the x minus 5 equals 0 or the x plus 4 equals 0. So we set each expression equal to 0, and then we have created a little tiny equation that we can solve. Take the x minus 5 equals 0 and add 5 to both sides to get x equals 5. And for the x plus 4 equals 0, subtract 4 on both sides to get x equals negative 4. This provides us a solution set of negative 4, 5. These are the two solutions to our equation. Always a good idea to plug everything back in and check. So we have x minus 5 times x plus 4 equals 0. First we'll plug in the 5. 5 minus 5 equals 0, and 0 times anything is 0. So 0 equals 0. Now plug in the negative 4. So we have negative 4 minus 5 is negative 9. Negative 4 plus 4 is 0. So negative 9 times 0 equals 0. Making the left side 0 and the right side 0. So 0 equals 0. And this is our dear friend, the zero factor property, which is what allows us to solve for x for quadratics.